More and more companies are developing and operating their APIs on the cloud, such as AWS. But how confident you can say your APIs are secured? And also how to actually enforce the security posture of your APIs? To answer those questions, let's take a look at those common API security challenges. So just to give you a bit more context, and let's assume you are the security staff in your organization who's responsible for operating and securing the APIs within your organization. And we have different type of the APIs, but here we focus on the REST API, given this is one of the most commonly used API type on the cloud. And so in this case, we have the API server sitting in the middle, connecting the front-end client as well as the back-end resources, which include the object storage, such as the S3 bucket, the web server, and the functions, like the Lambda function, which can talk to the back-end databases. So everything works all fine until some of the specific attack occurs. Firstly, you found the user authentication was broken, which means the malicious attackers can actually use the compromised user token to call your API servers. So you try to look into this issue to do some of the troubleshooting on top of your API servers, and then you found some of the issue on there, which is actually lacking the required logins and alerting mechanisms, which actually impede your further investigation. And think about that at the same time, coincidentally, the DDoS just occurred. And a large amount of the abnormal traffic just hitting your servers. And many of your users just start to complain that they can't access your endpoint and keep receiving the error code from your API servers. So just keep in mind that this is just a subset of the API security challenges. If we unveil the whole pictures, so those common API security challenge would also include the excessive data exposure to the injection attack, such as SQL injection, all the way to the function level of the authorization. So this is a very busy slide. Let's focus on the common security challenge at the moment. And actually, all these security challenges are from the API OWASP Top 10 Security Challenges for your API security services. And for those of you who are not familiar with the OWASP, it actually stands for Open Worldwide Application Security Project, which is a nonprofit foundation that's focusing on the application security ever since 2001. So now we understand these common security challenges. So the next question is, how can we actually solve them? And because there are so many bits and pieces spread across the board, the question is, where would be the best place that we can actually start to thinking about the solution? So this is where the AWS Well-Architected framework can come into play, specifically the security pillar. So the AWS Well-Architected framework, the security pillar, can actually provide us the guidance specifically across 6 different areas. So these are IAM, detection, infrastructure and data protection, incident response, and application protection. The framework itself also provides the design principle with the best practices associated with that. So for example, one of the security design principle is to apply the security at all layers, with the best practices to minimize the security attack surface, as well as how to use the AWS managed service to achieve this goal. Last but not least is that the AWS Well-Architected framework, specifically the security pillar, not only provide us for how the good looks like, but also how can we actually get there with the implementation guide. So literally, these are specific service recommendations as well as the best practices for how can you actually implement this service to secure your security postures. So now with the Well-Architected framework in mind, we can take a look at the OWASP security challenge model again. So what we can do is actually map those security challenges into the specific security area underneath the AWS Well-Architected framework. So again, these areas are IAM, detection, infrastructure and data protection, incident response, and application protections. And each area actually provides you a lot of information around what are those best practices and what type of service that you can actually use, right? So you can save a lot of time to find out the right solution to secure your APIs. So just as we mentioned, we can actually take one step further to map those AWS native service into a specific area to help you to secure your APIs. So for example, you can find IAM and Amazon Cognito underneath the IAM or access control area to secure your APIs. So that's very important. It actually saves you a lot of time and effort to find out the right service and the best practices to enhance the security posture of your APIs. So now you understand the framework that we can use to secure our APIs. Next, let's take a look at some detail level of the architecture that we can put in place. Alright, so in the first scenario, we're looking at the private API gateway endpoint. So the AWS service that we're using to build and run the API endpoint would be the API gateway. So if you're not familiar with this service, it's actually a managed service from AWS, which allows you to define and build and operate the APIs on AWS without managing the underlying infrastructure. Right? So you just need to basically specify the API endpoint type that you need to create. In this case, we're looking at the REST API, and then the system or the AWS account pretty much automatically provision the resource that's needed to support the API. So it's quite a handy way that many of our customers would use this service to support their API endpoint. And in this case, the API gateway actually sitting in one VPC, let's call it VPC 2, and then it connects to the Lambda function within this VPC. And the use cases was actually trying to expose the Lambda function towards another VPC through this API gateway. So as simple as that. So based on that, we don't necessarily need to expose this API to the internet. That's why we keep it as a private API gateway, and then there's no internet access that we expose within this environment. And if we look at the other VPC, this is the client side. And from the client side, let's assume we have an EC2 instance running the automation program that will be calling the API gateway endpoint. So the way that we allow the EC2 instance to call the API endpoint is to, through the VPC endpoint here, right? So, and in between the VPC endpoint and the API gateway, we have a technology from AWS called the private link that would interconnect the VPC endpoint and the API gateway that's sitting in another VPC. So this is our architecture, right? And at high level, again, because this API just need to be exposed towards another VPC that managed by our organization. So we won't expose this API endpoint to the internet. We keep it private. All right, cool. So based on that, the first thing to think about is how can we enforce the API that we manage and host by this API gateway, right? And if we try to recall the Well-Architected framework, the security pillar, one of the design principle was to implement a very strong identity foundation. So if we think about that, we actually can utilize the service called the resource policy from the API gateway side, right? Resource policy, and then we use this resource policy to define who can get access to the API gateway under what type of circumstances. Let me just zoom towards this side so we can see. Right, so for example, let's make it more specific. Within the resource policy, we can specify what type of VPC endpoint can get access to the API gateway. In this case, we actually minimize the attack surface, which also align with our best practices. So this is the first thing we can do, okay? And if we're looking at the other side, the other VPC, we can actually define another resource policy again. Resource policy, right? So we can define another resource policy, just bear with my writing, to actually define who can get access to this VPC endpoint. So what that means is we actually add another layer of the protection to prevent malicious attackers, right? More specifically, in this case, within this resource policy, we can define, for example, the EC2 instance with a specific tagging that can get access to our VPC endpoint, right? Cool. And what else we can do on top of that? Actually, there's one more thing we can do. Let me just scroll to here. We can actually define, bear with me. So we can actually define another identity-based policy for the EC2 instance. In this case, it actually would be the instance profile, right? And within this instance profile, similarly to the previous resource policy, but what we can do within the instance profile is that we can define what type of a resource, the AWS native resource, that this EC2 instance can get access to. In this case, we can define, hey, for this EC2 instance, you can only get access to this specific VPC endpoint, right? So we can also add additional layer of the control for the VPC endpoint access. And what else? Actually, if we look into this VPC endpoint in more detail, it actually is a interface endpoint. So what that means is it actually worked a little bit like an ENI, right? Like a virtual interface. So in this case, we can actually put like a bracket right here to just represent this is a security group. So we can associate a security group with this VPC endpoint to specify, hey, what type of IP segment the CIDR range can get access to the VPC endpoint. You can also specify the protocol as well. For example, like HTTP. So basically, additional layer of the control can be put in place in this way. So this is the first type of the API endpoint that we're going to cover, which is the private API. Next, let's take a look at the public API. In the second scenario, as we shown here, we have the API gateway sitting within our VPC, connecting to the backend Lambda function, and then to expose the API endpoint towards the internet and the public users, right? So that's a major difference compared with the first scenario, which is a private API endpoint. So to do that, we need to define the API endpoint in either type of the API gateway. So you can define it as an edge-optimized API gateway endpoint or the regional API gateway endpoint. So we can come back to this, the major difference for this two API endpoint. But keep in mind that both type of the API gateway endpoint can be exposed towards the internet or the public users, right? So cool. So fair enough. So in this case, let's say we have the client here. Let's just show a client, right? So the client needs to just go through the internet, and then to get access to our API gateway, right? In this way. So the question is how to secure our API endpoint hosted by our API gateway, right? If we try to recall the best practice from the Well-Architected, the first best practice or the design principle is actually ask us to set up a very strong identity foundation. How to do that, right? So apparently we don't want the client to just get access to our API gateway directly without any authentication. Instead, we will need to set up the authentication level. In this case, we actually would be using a service called the Cognito from AWS to do the API request authentication. So how to do that? Basically, for those of you who are not familiar with Cognito, it is a managed service from AWS that provides you the public users authentication service, so you can authenticate the user request before you can let them, actually access your API gateway endpoint, right? As simple as that. So the way that Cognito allows you to do the user authentication, there are three different types of the option in general. So the first type is that it really depends on your business use case. For example, if your use case would be that your user already have their user profile created in other identity provider, so most likely would be the social network identity provider, such as Google or Facebook or some other common social network or the identity provider such as Amazon as well. So Cognito already have the native integration capability with all these social network in terms of the identity provider integration. So you just need to configure on the Cognito and then to build up the trusted relationship between Cognito and this identity provider, and then so you can allow your user, which is here, to utilize their existing user profile in those identity provider to get authenticated against your Cognito, right? So this is the first type. And what about the second type? So if we try to look at the first type of the authentication, basically was fit for the public user. But what if we want to expose our APIs to our corporate internal users, right? But again, still expose that towards the internet so they can access the API service from the internet. To do that, we can actually utilize the existing identity that most likely has already been created and managed by the Active Directory or the other OIDC or the other solution that's compatible with OIDC or the OpenID Connect type of a protocol, right? So you can use the Cognito to do the integration with AD or the other OIDC identity provider such as Okta, and then to do that. And if you have the third different scenario, which is your user don't have the existing user profile, right? And then you want to use the local user profile within the Cognito. Can you do that? The answer is yes. You can utilize So you can utilize a service called what? Called the user pool. Just bear with me here. I'll put it in this way. So the user pool is the feature from the Cognito where you can define the user profile information such as a username and first name, last name, email address, and whether or not the user need to use the MFA or the multi-factor authentication to get access, right? Or get authentication. So these are the three main ways that you can use a Cognito to do the user authentication. And the flow will be like this. The user, first they need to get access to the Cognito, and then you need to choose one of the ways to authenticate your user. And what happened after that? So after your user got authentication against the Cognito, they from the client side, right? So the client, depending on how you define your application, it could be the browser or it could be application running on your cell phone. And basically, the client, once it got authenticated against the Cognito, it would retrieve the authentication token from the Cognito, where the client would be able to use that token to get access towards your API gateway, right? And now, let's assume the authentication has already been done. Then from the the data traffic perspective, would you like to allow the client to get access to the API gateway directly? That's the key question, right? If the answer is yes, and then let's come back to here, you would use the regional API gateway to implement your API endpoint. If you don't want to expose your API gateway to your client directly, instead, you want to only allow the client to get access to those APIs through the CloudFront, right? Then you would choose the edge optimized API gateway. This is what we are writing here. So let's put a box here called the CloudFront. Cool. Right, so for those of you who are not familiar with the CloudFront, this is the CDN or the Content Distribution Network service from AWS, which is also a managed service, right? So if you choose the edge optimized API gateway, and then the CloudFront distribution will be, managed by the AWS, which means that you don't have to to set up a lot of detailed configuration on top of that. And also, it is one of the fastest way that many of our customers can actually go global in a short period of time, because the CloudFront can utilize its global edge network to allow your client to send a request towards the the POP or the point of presence, right, from the CloudFront, which is the closest point to your client. So which can increase the performance and just decrease the latency, right? Which is great. In that case, within the CloudFront, one of the good ways is that firstly, the client is not hitting your API gateway directly, so you provide another additional level of the protection. And also you can do additional, authorization on the CloudFront, because you can define, the additional check on the CloudFront, and then to look into, for example, whether the request from your client will include a specific HTTP header, right? So these are the additional authentication that you can do. So great, now we have the CloudFront, and then we can use the CloudFront to talk to the API gateway. And what about the DDoS attack that we just talked about? When we think about the DDoS attack, actually CloudFront would provide a larger capacity to absorb those abnormal traffic. But from AWS, we also provide another service which is called Shield, right? For those of you not familiar with this service, this is a managed service from AWS, which provides us the capability to protect the user, from the common level 3 and level 4 type of networking attack, such as TCP or UDP floods, right? And in this case, let's say we choose the Shield Advanced. And from the Shield Advanced, it actually provides additional, capability to prevent those DDoS, not prevent, but protect, and also provide advanced, metrics capability to look at how severe the attack is. So you will have basically more data to understand your, networking profile. So the traffic will be something like this, right? The client goes to Shield Advanced, and then we can go to CloudFront. Great. So this basically aligns with our design principle, which is, apply the security at all different layers, right? And to do that, by the way, apart from the networking layer, we can also integrate the CloudFront with another service called the WAF, AWS WAF, or the Web Application Firewall. So this is another managed service from AWS, which provides you the application level of the protections, right? Because we're talking about different type of the attacks, some of the attack will be at application level, such as SQL injection attack, or some of the attacks that might be, targeting the specific operating systems, such as Windows or Linux. So in that case, you can use a WAF and then to define the WAF rules, right? Or you can utilize the WAF managed rules to, prevent you to be impacted by those application layer of the attacks. So, for example, some of the WAF managed rules are actually, defined based on the OWASP threat model, as we just discussed. So here we have WAF, which already, incorporate the level 7 application layer of the protection, which is great. And again, what we can do against the CloudFront as well. Another service we can do is actually what we call the ACM, or the AWS Certificate Manager, because the CloudFront actually can, terminate those HTTPS, requests. And with the ACM in place, we can actually rotate the HTTPS certificate on a regular basis, which provide us another level of the protection. Great. And one more thing to talk about is, apart from building a very strong identity foundation and also apply security at all layers, one of the other security design principle is to maintain the traceability, which means that we need to, to manage and to host or to obtain, to reserve those logging data, right, from our service. So we will have the visibility when the issue happens. We can look into that and to do the troubleshooting. And one of the pattern we can think about is to utilize the, let me just zoom here. Bear with me. Draw a box. We can utilize the Amazon, the AWS Kinesis, and specifically the Kinesis data file host, and which is a managed service for streaming the data, right? In this case, we actually would be streaming the log data from the service like WAF, and then to stream those data into the S3 bucket, right? So with that, we can actually stream those logging data in near real-time manner. So for example, we have all the logs here. And with that, you can actually utilize the other analytics tools, such as Athena, to analyze those API request logging, and then to identify if there's anything abnormal that's happening there. And of course, when we talk about the logging, right, the other logging service that come into mind that you can use would be like the CloudFront. Sorry, not CloudFront, the CloudWatch. So I just put it here. And then you can use the CloudWatch to monitor, the operation status of your API gateway. So pretty much that come up with the big picture for how can we set up the protection architecture for your API, which is the public API. I hope you get a much better idea for how to protect your API gateways or API endpoints using those native services from AWS and aligning with the well-architected best practices. So this is more succinct and brief view to summarize what we discussed so far. And just keep in mind that to start with protection of your API gateway, think about those best practices and design principles from the well-architected framework, which can help you actually lay up a very comprehensive security foundation for your API protection. So again, just a quick recap here. We can actually use the Cognito, right? The service like Cognito to set up a very strong identity foundation for your user authentication. And then we can utilize the other AWS service such as Amazon CloudWatch, CloudTrail, or AWS Config to maintain the traceability or the logging or the monitoring data, right, for your APIs, so we can do the troubleshooting or further investigation with ease. And last but not least is that here we've shown just a multiple different AWS networking layer of the services that can also align with our WAF, which provides the application layer of the protection. So this basically represents how we can do and the API protection at multiple layers. Now we come to the end of this video. I hope you enjoy it, and if you find it useful, please give it a like so I can see if it is of interest to you guys and whether or not it's worth to develop another video just focusing on how can we actually demo the real-life environment to utilize the service that we discussed today to protect our API endpoint. So that's for it. Again, give it a like, and I will see you guys next time.